Betelgeuse, an enormous deep-red supergiant in the constellation Orion, has captivated humankind for centuries with its striking color, radiance, and vast dimensions. Scientists have determined that if Betelgeuse were situated at the center of our solar system, it would devour every planet in its path up to Jupiter. The enormous scale of this star suggests that it is nearing the final stage of its life, preparing for a calamity-inducing explosion known as a supernova. However, in recent years, Betelgeuse has displayed highly unusual behavior. Its light intensified by more than 50%, elevating it from the 10th to the 7th brightest star in the night sky. This surprising flare-up drove researchers to seek explanations immediately. Was it a premature sign of an imminent explosion or merely a brief alteration in its natural cycle? The repercussions would be vast. Should Betelgeuse detonate into a supernova, it might shine so brightly that the night sky would resemble daylight, providing superior scientific opportunities. A star's brightness is impacted by its volume, surface temperature, and distance from Earth. Betelgeuse, over 700 times larger than the Sun, is cooler with surface temperatures of approximately 3,000 Kelvin. This lower temperature gives it its distinctive shade of red. Its enormous scale combined with its cooler surface heat makes it one of the top contenders for a supernova, rendering its current behavior even more fascinating. At the end of 2019, scientists were once more amazed when Betelgeuse dimmed to just 40% of its standard brilliance. This dramatic shift triggered widespread surveillance and debate. Some thought interstellar dust obscured the star, while others believed internal mechanisms were responsible. The possibility of an imminent supernova became a major focus among experts. Using the Very Large Telescope VLT in Chile, researchers captured high-quality images of Betelgeuse during this dimming phase. These revealed the star to be clearly out of balance. Further examination suggested the dimming was likely caused by a massive ejection of surface material which Betelgeuse expelled into the vacuum of space. This unprecedented event reshaped the star's appearance and disrupted its pulsating rhythm reminiscent of a volcanic eruption, but on an astronomical scale. Betelgeuse released more than 400 billion tons of material, far surpassing typical solar eruptions. This event not only altered the star's appearance, but also shortened its expansion cycle from 400 days to just 200. These significant changes suggested that Betelgeuse is becoming increasingly unstable, raising the question, how much longer can it maintain its current form? Astronomers, noting its erratic behavior, have intensified their efforts to observe it closely, actively searching for signs of its imminent collapse. When a massive star like Betelgeuse exhausts its nuclear fuel, its core crumbles under its own gravity, triggering a supernova. This colossal burst releases immense energy, hurling the star's outer layers into space in a spectacle visible even in daylight. If Betelgeuse were to explode, the first warning would be a burst of neutrinos, tiny, nearly massless particles that escape the core and reach Earth hours before the visible light arrives. When the light does come, Betelgeuse could outshine the full moon, casting eerie shadows and illuminating the night sky for weeks. A supernova of this magnitude would provide scientists an unparalleled chance to witness the death of a star in real time, deepening our understanding of stellar lifespans, fusion reactions, and cosmic processes. To better grasp Betelgeuse's odd behavior, researchers are using cutting-edge simulations of the star's internal structure. These models, built on data from the James Webb Space Telescope JWST and the VLT, suggest that a massive gas cavity may have formed near its core, altering its pulsations. JWST observations have also revealed intricate dust and gas clouds surrounding Betelgeuse, further evidence of its instability. While estimates suggest Betelgeuse could explode within 10,000 to 100,000 years, its unpredictable behavior hints that the time frame might be much shorter. By the end of 2023, JWST revealed even more alarming findings. The star, already weakened by massive surface ejections, appeared to undergo a rapid internal collapse. Astronomers observed drastic shifts in its core dynamics, disrupting ongoing fusion. Its surface pulsations, once steady at 400-day intervals, abruptly shorten to 200 days, clear signs of deep internal instability. Models indicate the core is beginning to fuse heavier elements with iron forming. Unlike lighter elements, iron fusion does not produce energy. Instead, it builds up until the core collapses completely, a star's final chapter before death. Betelgeuse's recent activity has sparked debate among astronomers. Some argue the explosion could occur within a few hundred years. Others insist it could still be thousands of years away. Regardless, it is evident that Betelgeuse's time as a red supergiant is nearing its end. A major warning sign of an impending supernova would be a surge in neutrino emissions. Scientists around the globe are monitoring Betelgeuse for this fleeting signal. Though the supernova will be a dazzling celestial event even visible in daylight, astronomers reassure us that Earth is not in danger. Still, its brightness may rival the full moon, casting ghostly shapes and illuminating the night for extended periods. This event will not only entice sky watchers while also delivering real-time opportunities for scientific study. The tale of Betelgeuse proves the universe continues to be full of mysteries that remain unsolved. This enormous star that has astonished civilizations persists for generations. To test our comprehension of how stars evolve and behave, like Betelgeuse dimming keeps surprising us, eruptions and erratic activities, it reinforces just how much remains to be identified. Its subsequent explosion presents a unique occasion to study the direct death cycle of massive stars. Understanding these procedures surpasses one star. It aids us discover how galaxies function, the distribution of significant components, and even the very groundwork of life itself. Our understanding broadens our perspective on the cosmos and our role within it. Tools for modern observation from systems based on the ground, like the VT, cutting-edge devices like JWST, have made exciting new entrances into the indications that an imminent supernova cosmos that were once confined towards science fiction. These technologies support simulations, astronomical research behavior, and cosmic explorations history that aids in understanding the structure of reality itself. Scientists such as Neil deGrasse Tyson's discoveries' passion and urgency are fueled by nature. They challenge conventional wisdom and encourage ongoing cosmic research. When you look at Orion's belt the next time, keep in mind that glowing one points tells the tale of a star nearing its destiny. What are your thoughts? Are we witnessing a star's final glimmers ready to burst, or is this just another curious phase in its existence? Participate in the discussion about one of the most captivating stars in the universe. Don't forget to turn on, subscribe, and like notifications for even more captivating cosmic stories that take your breath away. Keep an eye on until the next time. The skies. As we keep observing, one truth about Betelgeuse and its behavior becomes unmistakable. This star is much more than just a passing light up there. It's a business laboratory giving scientists access to rare insight into the subtle forces behind giants' life and death stars. Every flicker and brightness, every burst of material released, and every sudden change in how it pulses pattern tells us about the fundamental stellar mechanics existence. One of the most memorable aspects of the transformation of Betelgeuse is that it only occurs in a very small number of phases of star formation. As a red, it is supermassive and in its final act, but the path to supernova is completely different. Straightforward. The exact reasons for its irregular behavior are still under scholarly investigation, while the majority, one of the most notable, is the ejection event. The largest ever recorded, it could merely be the opening act in a more complex sequence that concludes with the stars fall apart. Equally intriguing is the notion that the explosion in Betelgeuse might reveal answers to some of the most fundamental issues in astrophysics. The death of a star like Betelgeuse could uncover secrets about dark matter, the universe's expansion, and the complex processes that create stars and planets. These revelations might improve our cosmological theories and enhance our comprehension of the billions of years of progress. Research into Betelgeuse belongs to a global scientific endeavor to comprehend the final stages of massive stars' phases, seldom seen as they unfold. Could Betelgeuse be more than meets the eye? Since the majority of celebrities die in extreme distances and over enormous time scales, a star with potential like Betelgeuse, signs of an imminent explosion, offers an extraordinary platform for observation. One unresolved question remains. Just how long does Betelgeuse have before it explodes? It's still unclear when it will happen, with astronomers constantly updating their predictions as new data become available. It may sooner go supernova, according to some, than anticipated, whereas others believe that we may still be waiting for millennia. Either way, the excitement around the stars. The dramatic conclusion is obvious. For now, scientists continue to track Betelgeuse with a collection of effective tools, both Earth-centered, such as the VLT, and orbiting like JWST. What we get out of these are models of will be improved by observations, evolution of stars, and enrich our comprehension of the forces of the universe that shape the world. As told by Betelgeuse, it continues to be a profound symbol of the extent and depth of the universe. While numerous stars have remarkable transformations that few provide such a clear view into the final stages of stellar existence, its forthcoming, the supernova, is likely to be significant in moment, an occasion that gives researchers unravel the cosmic secrets layers and broaden our understanding of the stars, galaxies, and the entire universe. Betelgeuse's release date is unknown. Will explode? One truth is certain. Its death will be a significant turning point in the history of astronomy. For researchers, it represents a memorable time in discovery. It's safe for the rest of us. Stunning reminder of the awe-inspiring, the surrounding splendor and mystery.